Do you have everything ready over there?
Yeah, I think we're good to go.
Did you click it already?
Yep, you're on. Don't worry about it. Have it be in the background. Alright, so welcome everybody to Ryan's talk on a developer's guide to password security. He's going to help us understand a little bit better how to work with passwords in a secure manner. So go ahead, Ryan, take it away.
So thanks for coming out. So my name is Ryan Buteau. I'm an offensive security engineer. Basically, I get to be the bad guy. I find vulnerabilities, exploit them, and then work with developers to fix their security issues and mitigate risk. So tonight we're going to be talking about what makes a good password. We're going to crack some passwords and then learn what you can do to slow hackers down, both as a developer and as a user. So what makes a good password? The first component in a good password is length. You can see the permutation calculation up here is the total available number of characters raised to the power of the length of your password. So typically, if you have 95 different characters to choose from for your password, and your password length is 1, you have 95 combinations. If you add just a single character to that password, you're going to end up with over 9,000 combinations. And for each additional character that you add, you can see it gets exponentially more and more combinations possible. So what happens when you have to crack these passwords is for every one of these combinations, you need to generate that combination, you need to hash it, and then compare it against the hashes that you're trying to break. So you can imagine that when you start getting upwards of 12, 14, 16 characters, it's going to take a lot longer for someone to break. You can't exactly have 12 characters, 12 letter A's and expect to have a secure password though, which brings us to the next component, which is entropy. So entropy is the measurement of how random and unpredictable a password is. You can accomplish this by using a diverse character set within your password and avoiding the use of common words, phrases, usernames, and personal info like your name, your dog's name, where you live, your birthday, easily identifiable information. Those things don't make good passwords. So I do have a few examples on the right side here of good passwords. The top 3 are all 16 character passwords using a mixture of uppercase, lowercase, numbers and symbols. Those have extremely high entropy. The 3 passwords below that are bad. It's my dog's name, when I got her, my name, my birthday. Like these things are all make for weak passwords. One thing to note though is that all of those passwords would pass a website validation. Like when you're creating an account and you enter something like that in, like Lucy 2018, it's going to tell you, yeah, that's fine. That meets their requirements. So now that you guys have seen how length makes your passwords exponentially more difficult to crack and entropy makes those passwords completely random, you're probably wondering, how do people even begin to crack these passwords? And I'm going to tell you, it's because you're bad at making passwords. And so is everyone else. People make bad passwords because people make passwords that they can remember. They follow patterns, like sequential patterns for ABC and 1, 2, 3. You have keyboard-based patterns. Going down the left side of the keyboard, you would have 1, 2, QW, AS, ZX. And you have time-based patterns. So winter 2019. Can anyone guess what that guy's password would be in a couple months when it expires? No. You also have common words, such as password, administrator, and phrases such as let me in. There's also rules that people abide by. So I'm sure that you guys have seen when you sign up for a website, it tells you need at least 1 uppercase, 1 lowercase, a number, and a symbol. So how many of you guys have actually done, uppercase first and then end with a number or a symbol?
not telling you.
I mean,
my password.
Like that's a common rule that people follow. The next rule here is also pretty common, replacing letters with certain characters and numbers. And then there's this next rule. Can anyone guess what was done to that password to make it look the way it does?
I'll go last. I'll let somebody else guess first.
What's that? Yeah, that's exactly it. So you actually, get a little prize. It's a totally not malicious USB device to plug into your computer. It's a data blocker. So if you're charging your phone somewhere public, you can plug your phone into that, and it will sever that data connection so that you can charge safely. So yeah, no problem. I'm glad someone guessed it that fast. Yeah. The original password was password, shifted up one row. So now we can actually get to a demo, which is the main part of this talk tonight. All right, so we have a file here that has just about 6,500 password hashes in it, and we're going to break as many of those as we can. I'm using just a basic, MacBook Pro. It's nothing special. There's nothing added to it. This is pretty common for someone to have, so we're going to see what we can actually get done with it. So one of the tools I'm going to be using today is it's called Hashcat. And so what Hashcat is a tool used to enumerate a file of hashes. You tell it the type, and you can give it a word list, a different attack mode. We're going with A3, which is actually going to be a brute force style attack. And we're going to be looking at MD5 hashes, which are extremely common out in the wild. When you find a hash, a lot of times it's MD5. So that's what's in this file here. So we're going to pass in the file name. Then we're going to do an incremental brute force attack, where we're going to give it 6 characters, up to 6 characters to look for. So what you see on the screen right now on the left side is the hash, the original hash that's in that file. The right side is the password, the input that then gets converted to MD5. So the original password. And I'm not going to let this run all the way, because if we look at the status here, it's going to take almost a half hour. So I can show you some better ways to crack these passwords.
Do you get flagged in some database if you download Hashcat?
So typically, we would extract these hashes from a database or from a shadow file or wherever else they would be stored, and then do this stuff locally. So I'm using just a MacBook Pro right now. The GPU that I use for at home on my desktop, just for playing games, again, it's nothing special. It actually is broken and crashes a lot right now, but even that will go through this entire file in less than a half hour and crack most of it. So I'll end up showing you guys that here in a little bit. At work, we actually have access to a rig that's used for machine learning, but that uses Tesla GPUs, and that is exponentially faster than this. We would have been done a few seconds in. So I'm going to quit this, and we're going to look at a better way to crack these. You can see that we managed to crack 127 of those passwords, though. So what I'm going to do from here is we're going to look at, instead of doing an incremental password break, we're going to do 6 characters ending with a number. So like we just said, I'm going to go with the rules ending with either a number or a symbol. It's very common. That's what we're doing here. So these are all 7-character passwords, anything ending with a number. But again, it's pretty slow. We can do better. So we're going to quit out. Right now we have 146 out of the 6,500 cracked though, and it's only been a couple minutes. So we're just over 2% here. So we're actually gonna change it up. Okay. So now we're going to do a dictionary attack. So the difference here, the first attack being a brute force was we were generating every possible combination of characters that we were telling it to use. So that question mark A was basically a parameter saying use any available character. So again, we're going to do MD5. Give it the password file. And now we're going to give it a word list. And actually, I'm going to clear this out for a second. I just want to show you guys this word list here. So it's got 128,500 words in this dictionary. So there we go. So that was fast. Dictionary attack is much faster than brute forcing. We managed to get one additional password there. You see that 13 Lexon. So it's not a very good list. So what we're going to do is use a better list. This one here has almost 14.5 million words in it. So if we pass this one in, and see what happens there. So we just managed to crack a bunch more pretty quick. And again, remember the previous slide that we looked at was rules. So those are pretty common rule sets, manipulations to a password that people typically do. Those rules are known by attackers as well. And so what they've actually done is put together different mutations that you can do in a dictionary attack. So you take a word and then you modify it. You can turn those letters into numbers and symbols. You can append some numbers at the end or some symbols. You can make that first character uppercase. You can do whatever you want to these. So we can look at one of those. So we're going to look at best 64. And this is just super basic, 102 rules. And we're going to pass in that exact same word list that we just did.
So does that modify the word list using the rules? Is that what you're saying?
Yes. So it's going to iterate through that word list that we just looked at. And now it's going to modify those contents. So now we're getting a lot more passwords. So now we're at 421. So we just added about 250 more passwords to that list in 15 seconds. So what if we use a better word list?
What makes one word list better than the other?
How many words are in it? And when I said word list, I meant rules.
Oh.
So, but also same thing, rules. So we're gonna look at this set of dive rules. It's just this has 100,000 in it. So the one we just looked at was 100. This has 100,000. So this is taking the Rock U word list that we looked at originally, and we ended up with 181 words that were in the Rock U list. Now we're modifying it, and it's just cruising through, breaking as many passwords as it can get. And this could definitely go on for quite some time. It would go on for 3 hours. Instead of making you guys wait 3 hours, I'm going to step it up to an even better set of rules.
Wait, there's more.
And so this set of rules actually has 125,000. So essentially the one that we just looked at, but even more. So one thing I also want to show you guys is, this talk is about password security. So at the moment, you guys know what makes a good password. You're seeing how they get broken. One thing though to keep in mind is that it doesn't really matter how long and complicated the password is if it's going to be easily accessible and readable. Like if you have server misconfigurations or you have developers who are putting stuff where it could be publicly read. So I want to show you guys some of that stuff while this is running in the background. So this.
Sorry, I didn't
Yeah.
cut you off, but what is the difference like with a hashing algorithm that's acceptable, like SHA-256, for example?
Yeah.
Do you find, is it just as easy, or is it considerably more difficult? Can you use the same tool?
Yeah. So so the difference between hashes is the amount of processing power it takes to calculate that hash is one thing that makes it a good hash. Also, the hash length is important. Shorter hashes have more of a chance of collisions and things like that. So yeah, like SHA-256 is like the industry, that's as low as you want to go,
Right.
but that's kind of like the industry standard. For hashing, 512 is better, and then there's even better password hashing algorithms that are made specifically for passwords.
So if you were building an application right now, and you were doing some kind of an authentication module, what would you choose for your hashing algorithm for passwords? Or would you offload it to another?
So I'm actually going to go over that right after this one.
Sorry,
So
go
no,
ahead.
no worries. But you'll see, and you'll see why too.
Got it, okay, thanks.
So what we're going to do is this is just something. It's Google hacking. It's basically leveraging Google, which crawls the internet all the time. Leverage Google to see what we can find that's just sitting out there. And you guys as developers will probably know what's in here.
That's nice of Google.
Yeah. So as you guys can see, we've got some database names, usernames, passwords, the server. This is everything that you need to connect to that database. And there are 1,500, 1,600. This one here, patient view.
Oh, that doesn't sound good.
So patient view is gives patients direct access to live test results and other info, and they operate out of the UK. So being in the UK, they don't have to follow HIPAA, but they have their own data privacy acts. Is anyone familiar with GDPR? So GDPR, for anyone who doesn't know, is basically saying that you have the right to be anonymous and that your data needs to be protected at essentially all costs. The penalty for not being in compliance with GDPR is up to 10 million euros or 2% of your entire company's revenue, whichever's higher. So at the moment, we just did a quick Google search, saw a company that is leaving their server configurations to their database of live medical records, wide open. They're supposed to be in compliance with GDPR, and they're not. this would be prime for an opportunistic attack of, like, say, ransom, stealing that information. That's that quickly. So we're going to actually look at some other stuff. That was just Google. So let's look at GitHub. Here's their source code. So we search password. So we got some random password generators. We got some password updates, password reset options. Password is pretty commonly used in your commit messages. Setup mail, password reset, password change. What about the people who want to, like, secure their information a little bit better, and they want to make sure that people know that they've removed their password? So here's the root password. That's the same. Let's see. Remove password. That's good. So there's 578,000 commits here of people removing their password. That's great that they're being so secure. What about AWS keys? There we go. I know it's hard to tell, but these green lines right below here are showing that the information has been removed, so that's great. They're super secure. It's not in their source code anymore. There are 7,000 of these. These guys added an exclamation point, so they're being super secure. Yep. So we've looked at Google hacking. We've looked at GitHub. Is anyone familiar with Pastebin? Apparently I'm not. What is that?
Just keep hitting F5.
I don't want to look at whatever that ad is. Pop-up blocked.
It's telling you that they're under heavy load.
All right, I'm going to show you another Google example then while we wait. So here we go, 15,000 results. These are all basically wide open directories of machines containing the shadow file. If anyone's familiar with Linux, you know that the password and shadow files hold the hashes of user accounts. So if you want to, like, SSH into a machine, you've got that machine's IP address, you've got that username, and then their hash. You can take that hash, throw that into Hashcat, and attempt to break it. If you do, log in and enjoy your new machine.
At the drugstore.
At the drugstore. Yeah. Let's see if this loaded. There we go. So this is a ton of emails and passwords, and we can see with the $$P$, what that stands for. It's like an identifier, a signature for the type of hash that they're using. This one is for PHP, typically seen in WordPress sites. So if we were to take this list and start breaking these passwords, any successful break would allow us to, we'd probably test WordPress first with that email and password combination, and then give us access to whatever's on that server. Let's see how this is doing. Pause it. So we're at just shy of 1,900 so far, almost a third of the way through this list. And again, this is just a basic MacBook Pro. I'm not doing anything special. It's been probably a half hour, maybe not even a half hour that we've been doing this. Oh, it says right there, 10 minutes. So it's been 10 minutes. Yeah, so I think I'm just gonna quit this out. Does anyone have any questions so far before I jump back into some slides? All right. These are just the examples that we just went over. The incremental brute force, the masked brute force, dictionary attacks, and then rule-based dictionary attacks. This right here is the output from my machine at home. I ran through the entire NSA dive rule list that we were just going through. And you can see that in less than a half hour, we cracked about 4250 out of the 6500. So 2/3 of that list in less than a half hour.
Are these hashes salted hashes or just regular?
These are normal hashes. These are non-salted MD5 hashes.
Okay. Because if it was a salt, you'd have to do it differently, right?
Correct.
If you knew the salt, is this a tool you could be like?
Yep. Yeah, because the salt is typically stored in the database with the hash. It's not kept
So for
private.
each one, you just have to figure out how they salted it. Or,
Yep. And then you would pass that in like the hash file. Like you can pass in the username that you know with like a colon, and then the hash, and then another colon, and then the salt, and it will go through and figure it out for you.
I assume finding these rules are pretty easy.
Yeah, these are open source, readily accessible sets of rules. It was not difficult to find.
It's like your password's bad and you should feel bad.
Yeah, yes. All right, so now that you guys have seen what goes into a good password, you guys have seen what makes a bad password, you've seen how people break those passwords, what can you guys do as developers to slow hackers down? So this is the algorithm that you want to use. So protecting your users by using strong hashing algorithm. We were just looking at MD5, and MD5 is bad for passwords. It's fine if you just want to hash a file real quick and just see if things have changed. That's fine. It's fast. It's easily calculated. But the hash length itself is pretty short. So collisions are possible, which in a collision means that you can have two distinct inputs end up outputting the same hash. And then there's rainbow tables. Rainbow table is basically a pre-calculated database of passwords and their equivalent hash that basically negates the entire need for a GPU or supercomputer to generate those hashes and compare them. It's just like a database, a normal database at that point, that you can just throw whatever your hash is against it, check it, and it will spit out the password. So this lowers the barrier for cracking. Comparing that to bcrypt, bcrypt was specifically made for passwords. It's extremely expensive to calculate, and it has the ability to scale with computing power. So as machines become more and more powerful, you can actually scale bcrypt up to continue to be an effective solution. There's yet to be a collision, and it has built-in protections against rainbow tables. So again, protecting your users by spicing up your passwords with salt. So this completely negates rainbow tables. It ensures that no two hashes are the same. It increases the amount of time to crack. So what we were just looking at was Hashcat generating an input, generating that hash, and then comparing it against that entire list of hashes to see if any of them were a match. Makes it pretty quick. If you have a salt involved, you need to create the input, add the salt, hash it, and then that hash, because it's unique per hash, per input, it can't be, it's useless against all the other inputs in that hash file. So you're gonna have to do that work every time for every hash in your file. So down below here, quick example, you have user A and user B. You have the same input for each. They both have passwords as their input with no salt. Passing the same input into the same hashing algorithm will end up with the same hash. On the right side, you can see an example of salting. So you've got, again, the same users with the same passwords, 2 different salts, and end up with 2 different hashes. So one of the things that comes up a lot with security is that it's difficult, or it's time consuming, or we'll do it at the end. This is an example of implementing bcrypt with Python 3 in just a couple lines of code. This is showing the hash creation, so like a user registration, and then again at the bottom a login. So you've got import bcrypt that's getting the module imported. You've got your password set to super secret password. That's a good password. And then you have 2 lines down, you have the hash being generated by passing in the password and then generating a salt with bcrypt. And so that 14 there is the number of rounds that it's going to use, and that's how you can make this scale. That'll output the hash. You throw that in the database, and then you're good to go. When that user goes to log in, you check to make sure that their input matches the hash. So you get that hash from the database, you generate the hash with their password. If it matches, they're logged in. It's pretty simple stuff.
I remember looking at that before, but I forget. Where's the salt end up?
The salt is part of the hash in bcrypt. Yeah, so up here, 3200. There we go. So it might be hard to see, but you have the $2A.
You're in a different screen.
I sure am. Thank you. It might be hard to see because I'm not presenting it. All right. So this right here, we have bcrypt. This start here, the $2A, that's its signature that tells you this is bcrypt. So we got the hash, and then there's this period right here. Everything here after that period, that's the salt. So this whole thing combined would get plugged into something like Hashcat, and it would look at this and it would know that that's the salt, and then the hash, it knows that it's bcrypt, and it knows how to work. Same thing like when you're going to do the check. So when you're checking that password, there we go. So when you're checking the password, that hash is going to have the salt in it, and it will apply that same salt to this password and make sure that everything's all good. Yeah, verifies it, it matches, they're logged in, and doesn't match, not logged in.
Cool, thanks.
So that was how you can protect users as developers. So now we're going to look at what you can do to protect yourself. This is for when you're on, whatever applications that you're going to use. You got Facebook, Gmail, AWS, whatever. You don't know what they're doing to protect your password, so you got to, be aware of what you can do to protect yourself. So rotate your passwords. The average time to discover a breach is 197 days. The time it takes to notify customers is up to 60 days. And that's honestly if they even decide to disclose. There's a lot of companies who might find a breach that will just be like, we don't want to take that hit to the public image or their stock price, and they're not gonna do the notification. The number of breaches disclosed in 2019 was 3,800. By rotating your password, this allows you to hopefully stay ahead of a breach. If your account password is stolen, but you're going to change it in like a month anyway, attackers can only be effective for so long. And at that point, they're trying to maybe sell that dump of credentials, or they're still trying to break the hashes. Rotating the passwords is just something you can do to protect yourself. In addition to that, Avoid password reuse. This is huge. There's a very common attack. It's called credential stuffing, where basically if an attacker is able to compromise one set of your credentials, they're going to take those credentials and they're going to stuff them into every login that they can find. So if your Facebook account gets compromised, they're going to throw that at Gmail, Yahoo, Reddit, Azure, anything, in hope that you're going to use that same password somewhere else. Most people only have like 1 or 2 passwords that they use across all of their accounts, and this is a very real threat. So rotating your passwords regularly and having a unique password for every website that you use, that's going to be pretty difficult to do manually. So the next way you can protect yourself is to use a password manager. There's a lot of them out there, a lot of them that are free, they're open source, you can pay for some if you want. They can generate great passwords for you. Those 3 passwords that we saw earlier on were all generated by LastPass. You can set up whatever complexity that you want, the length of the password, it'll spit it out and you can use that. It lets you remember just one good password, just one password as your master password to gain access to every one of your other accounts. So it's easier than remembering hundreds of accounts. It's cross-platform, online, offline capabilities. A lot of them have autofill. I definitely recommend using them. I use LastPass. So again, for protecting yourself, multi-factor authentication, just kind of enable this wherever you can. Multi-factor, if you don't know, is usually a combination of any of these things down below. Something you know, which is a password or a PIN, something you have, like a badge or a smartphone, and then something you are. This is like biometrics, so fingerprints, voice recognition, retina scan. Now, where can you actually use two-factor? There's this neat little site that I'm going to show you. There it is. A neat little site here. You can search different websites, or you can look at different industries. And it shows you which of them offer, this is really hard to see on the projector, but if you look at the actual website itself, I can give out these slides at the end that you can check for yourself, but they show you which ones fall under different categories of multi-factor authentication. We got cloud computing. You see, like, most of them offer some kind of multi-factor authentication. So if you're not using multi-factor authentication, especially as a developer, you guys have like keys to the kingdom, really. Like, you're generating your tokens, and you typically have full permissions, full access to whatever you're doing. If your account gets compromised, which they're highly sought after targets by attackers as developer accounts, you guys can get them any access that they want. All right. So again, now you know good passwords. You know what goes into making up bad passwords. You've cracked passwords. You know how those passwords are stolen initially. We've gone over protecting your users, and we've gone over protecting yourself. So going forward, you guys are going to be completely secure, and there's no way that you guys can get hacked, unless you've already been hacked. So are your credentials safe? There's a resource here called Have I Been Pwned? This website here is made by a security researcher, I believe it's Troy Hunt. You can actually enter in an email address here, and it will tell you, it doesn't spit out the password, it tells you a breach that your information has been a part of. And so you get timelines, and you get company names that this where your stuff has been affected. Things like LinkedIn or Spotify. So I highly suggest taking a look at this site. If you own a domain, you can actually set up this notify me. If you can prove to them that you own that domain, you can actually set up auto alerts if any email under that domain comes in to this guy's list. You can see he has over 9 billion accounts in this list. And yeah, an alert will go out. So check that out. And if you show up in that list, come see me. If you're curious to know what passwords are out there of you, I can help you find out and get that fixed. So.
17.
We found in the list. Yeah. Yeah.
Stuff I don't even remember signing up for.
Oh yeah. That's how it works.
You'd be surprised when you try it.
Any of you guys have any questions?
What about password phrases? Like people talk about just doing like a phrase.
Yeah, so I didn't show any examples of that, but that's just another style of dictionary attack where the inputs can be generated from words
Together
instead of,
and then-
yeah.
So it's not really very good. Like it's
It's-
long, but it's not.
Yeah, so it meets the length requirement,
Right.
but the entropy side, not so much because it's words.
If you can think of it, they can plug it together.
Yeah, so basically if all the words that exist in your password exist in that list, and then they just do a brute force with the words instead of with characters, they can generate, like if you have 4 words and all 4 of those words are in that list, it's kind of essentially like having a 4-character password. I mean, it is slower because it's more than the 26 characters in the alphabet, but it's that kind of same effect.
Work emails clean.
Work email's good?
I thought he said worse. Work email's worse.
Gmail is completely
Everywhere.
Time for a new Gmail.
Yeah.
Anyone else have any questions?
So, going back a little bit to my earlier question, there are services out there that will handle authentication for you if you're building an application or whatnot. Do you know of any of these, or have any that you recommend?
Yeah, there's like Auth0 and what was it?
That's it.
One of them, yeah, Auth0 for sure. I'm trying to remember because I feel like Auth0 was bought by the other one that I'm trying to think of, or the other one was bought by Auth0, so then it doesn't matter. Auth0 is the first one that comes to mind, though.
Great. Yeah, I mean, that's...
Also, like, I mean, even like the built-in stuff for like .NET, anything, literally, like any of these existing things is better than rolling your own.
Right.
Do not ever roll your own hashing, your own encryption, your own password stuff. Just don't. There's too many libraries and resources out there readily available for you to use to go and try to do that. Yeah. So that stuff. And what is the phrase? Like anyone can build an algorithm that they can't break. Basically, is the term, I think. Is that it? All right. Well, thank you guys.
Thank you.
Nice work.